Hello everyone, this is Razi. I have made a wave generator that you probably have seen in the past. So I updated the entire design and include a function that allows you to generate multiple waves that can interact with each other. Meaning, despite the demonstration that you have probably seen in the past, I will give another example as well in this tutorial. Before we actually start, I just want to mention that in Blender, there are plenty of ways to generate waves. A very important thing is dynamic painting. The second is wave modifier. And the third is potentially the shader displacement. It means that you don't necessarily need to generate a wave using animation nodes. But I still think this is interesting and important because it's fully procedural, and as you can see from the demonstration, once you increase the noise, it gives kind of interesting patterns. Another thing I would like to mention is that after I have made a tutorial of Radio 4, I'm going to share the preset library for free on Gumroad in this week. It means that you don't necessarily follow this tutorial and build a preset for yourself, but I do recommend you to watch this tutorial to know the concepts so that you know how it has been built, why I made all these kind of settings, and can potentially customize it for yourself. So let's start. Here's a very basic setup of my wave generator list. If you hit Ctrl A and search, there is another wave generator that I've made. Basically, they're the same. The only difference is this wave generator loop can generate a single wave, but wave generator list can generate multiple waves. So here we have this customized valve being ticked on. If I don't tick that on, then it's by default it's using the object controller valve, but it's possible that you use other valve for whatever reasons. So here is just a one wave, and its function is exactly the same with the loop version of this wave generator. But once you duplicate this controller and scale it down or whatever things, then you can see we're generating multiple waves, and they do have ability to interact with each other. By changing this evolution, you can see how the waveform actually colliding each other and cancel each other, especially in the middle. So you can see there is a kind of interesting bridge that has been formed. So on and so forth. Basically, this is all about it. You can do more waves as you want, as many waves as you wish. It's fully procedural as you have seen from the demonstration, and so on and so forth. So let's start to talk about how to actually build this preset, or the principle behind. Before we actually head into building the preset, I would like to discuss several aspects of wave. So here's a very basic setup of a 2D wave that goes up and down. It's basically sine wave. You can learn more from the Wikipedia or the trigonometry in the textbook, but basically this is each time if you mention about a wave, it basically always goes to sine wave. There's another function that can do basically similar thing, or actually the same thing, is the cosine wave. The cosine, the only difference between cosine and sine is cosine starts from 1. So it will goes down and loop as the sine wave. But the sine wave goes up first, cosine wave goes down first. Usually, I think sine wave is more preferred than cosine wave because the sine wave will always start from the origin. But they're essentially the same. The only difference is they differ by 180 degrees, which is actually also a pi radius in terms of a unit. So here is a very basic setup of the sine wave. You don't necessarily talk about these two nodes at this moment. I generated a list using this float range. I put the list into X so that it will just extend itself on the X-axis. But I put the list also in sine wave and put that into Z-axis, so it will go up and down. And this is basically the nature of the sine wave, that it will loop itself. The loop duration is by default is 2 pi. it's basically a circle, as you will understand, because the circle loop itself. So it's basically the sine wave is, in this case, is just showing a circle in another way. So if you put that to the stop as 2 pi, then you just go back to the origin, and you just start another loop as you increase this stop. Several important aspects of this sine wave is that if you multiply a number within the sine wave, then you actually increase the frequency. However, if you're multiplying a number after the sine wave, which is actually means you are multiplying a number outside the sine wave, then you increase the amplitude. The normal sine wave goes from -1 to 1. However, if you multiply that by 5, then it will be -5 to +5. All these kind of things as you can potentially think. However, this is not a... So after this part, you know about how to generate a 2D waveform. So what are the methods to actually generate a 3D wave? So here I have a preset. You don't necessarily to know about this. It actually has been mentioned in the tutorial in the past, but you don't necessarily know this because this is not the method that we're going to use. This is just for demonstration purposes. Previously, what we see is a wave on a 2D plane. So it's basically any plane, but it's not going to be a mesh. So it only expands like x and z, but it does not curve at y. However, now what I'm going to do is basically replicate this 2D plane 360 degree, so that it actually covered. So we have a 2D plane 360 degree to mimic a sense that we have actually a wave on a 3D space. And basically this is it. As you increase the resolution or the amounts, then you get more and more like kind of waveform, and you can just try to increase the number or change all these values to do whatever you want. And actually this is a legitimate method that you can potentially create a waveform in a circular pattern. It's actually definitely doable. However, as you can see from the previous demonstration, is that we can actually generate a wave on a rectangle or actually a square. It does not really matter. Basically kind of a grid. Instead of a circular grid, we have a more kind of, I don't know how to actually describe that, but it's basically the idea. You can even actually generate a wave on a triangle using my method. But this is also a legitimate method. The only difference is it's only limited to kind of this circular structure. Okay. So here, what I want to say is, what you can actually see, it's the way to generate a wave, a 3D wave, is that you need to find a commonality of all these points at the same height. And in this particular case, it's because I'm using the same sequence. I'm just using this. I'm just replicating the same sequence at the different places, so that they finally form a sense of loop, or they form a sense of wave. But there is another approach that can potentially find a actual commonality of all these points. It's basically the radius of these circles. And following this principle, you can actually notice we're going to use a node which is called a vector distance. And basically this is the starting point where we are going to build the preset. So let's firstly delete what we just generated. And here I'm going to take a distribute matrices. And I'm going to put these vectors into A. So I'm going to evaluate all these vectors distance compared to the origin. But you can define this B. But we're just going to do that later. So now we have a grid, and I'm going to evaluate all these values. The distance is a single value instead of vectors. However, we're going to combine that as a combined. We're going to put all this distance into the sine function. So take a float mass, put a sine function. So now it starts to wave up and down, but it's still not a vector. What we are going to do is put this vector into the z. So now we only have points going up and down, but we need to plus basically a vector mass. Considering the fact that we're going to use a fourth to decide whether this wave will fade out or not on the plane, so we're going to use the fourth. And there are lots of fourth. In this particular case, we're going to use object controller fourth. However, the question is how to actually plug this fourth into the value so that it can participate with this vector mass. That's why in this particular case, instead of using the vector mass, it will be more easy that we just use these offset vectors. So now we put the vectors into the vectors and z into the offset. And now we can put the fourth into the fourth. And let's turn on our controller. And let's see about these new vectors. So now only this value that has been covered within the controller has been shown. So this is basically the principle of this preset. So to build such kind of function into a preset, let's start with a group input. And my expectation of this preset is based on not only working on the mesh, but also the vectors. So in the first input, I'm going to take a vector list. And I'm going to use this vector list to replace the vectors. And let's hit this output so that we can output the vectors. Just for safety, I also would like to have this wave information in case that maybe I would like to have an object floating on these waves. So I will name the one as the results and the other as waves. So this is my design. You don't necessarily follow what I'm doing, but this is what I'm thinking. Another thing is sometimes I don't want to have the wave generated at the origin. Maybe I just would like to move that. So now our group input is not a function yet. So let's create an evoke node. We just put the vectors into vector list and it will basically do the same. And what you can actually realize, so sometimes I don't want to have my waves working on the origin. And I would like to move that. So now you can see if I try to change these values, it will just move based on itself. It's possible that you just use controller's location to control this origin. So let's take a object transform input. And let's define an object. So I have this single object used that both as a object controller and the way to define the location. So now if I just reselect our controller, so it will work as the controller. It will work as the fourth, but also at the same time, it will be the origin of this wave generation. So now we basically finished the wave, but I would like to add some more control with the wave. And the principle is basically what I stated at the beginning about the sine function. So we're going to add a mass before the sine function, so all the value will be included in the sine, and this will turn to be the frequency. And let's put this 3D viewer outside the group node and take a look with the result. And if we plug this back to the input, and we can rename that as wave frequency. Also, I'm going to take this math behind the sine function so that this will be the amplitude, and select the multiply. And I'm also going to put the value b's back to the socket. And you can name that as wave amplitude. Just to be aware that sometimes maybe you want to change the default value. So what you can do is just to select this group input and hit U, and in this advanced setting you can change all these values, so that each time you call up these nodes, all these values will be used as a default. Another way to change the default value is you just hit N, and in the advanced setting it's basically do the same thing, just different ways. So now we have all these values, and you can change the frequency, and you can change the amplitude, which is very handy. And at some point, this is just the wave function that you can potentially work with. And actually, at some point, this is all about it. There's more function that you can potentially add. For example, you can add this offset back to determine the fourth. You can add the fourth width. You can also put the linear. If you want, you can also put a invert into that. But I don't see a point to put this invert. Actually, it might be interesting because it gives us a plane and waves around, so it might be interesting as well. But it's your preference whether to actually do so or not. Also, I think if you wish to have the ability to decide whether it's a custom fourth, as in my preset, so what you can do is add a switch. So you can add a Boolean input. And you can say customize fourth. And you can add a fourth. And this fourth will be going to the true, because if this customize fourth is hit, then we'll use the fourth, which is from the inputs of the subprogram. Otherwise, it will just use the built-in controller fourth. So it's completely your decision whether to make this thing, because I don't know how you will actually use this. Another thing, just to be aware that once you create a Boolean within a subprogram, it usually happens the default number is, it will be checked. But you don't want the default to be checked, I suppose. So you can hit this, you can turn this off. So by default, it will be off. So that if I just invoke the subprogram, the option is off, so on and so forth. And then we can put these outputs. So let's just shift the right click so that you cut with a reroute. Put the outputs into the socket. So replacement. Okay. And this is kind of basic setup. However, as I mentioned at the beginning, the thing I would like to use this setup is not to actually generate a wave, is rather to generate a noise. So now we have to consider how to actually generate a noise that has been shown in the demonstration, which gives a kind of very interesting look. And there are many different places that it's possible to add up a noise. For example, at the most beginning, and also it's possible after everything has been done, and so on and so forth. And my experience, or my experiment told me that it will be most interesting if you add everything at the most beginning. So here, firstly, let's break up this connection, and I will tell you why. So we're going to do everything with this vector distance, and it's quite straightforward that it's possible that you just add a vector math. So now it's the other socket is going to add a vector noise. So there are two types of noise that you can potentially think of. One is the vector wiggle, or random vector. It's basically the same. The probably difference is that vector wiggle can evolute itself. So it's possible that you add a vector wiggle, and you can make it turn into a list, and make this vector list into the count The only issue that you can realize is it's really a noise, and from point to point there is no connection to itself. So what it does, it will actually generate a lot of junky parts, bumpiness of your wave. And I suppose this is not what you want. If you would like to have a coordination from point to point, another method is actually really called a vector noise. And this is the node that you will see. And this node has recently just been updated. So originally you will only see the simplex options along with many other things, but now there's another type of noises. It's called blended noises. The difference is basically the faster noises use a external library which is faster. Blended noises sounds to be slower, but it's more kind of internal. So if you have used the modifier, displacement, or texture, you can see a lot of clouds or probably other things. I'm actually not sure how it actually exactly works, but you can try to see all these kind of fractals, turbulence, heteroterrain, and whatever stuff. I'm not going to check all of them, but I suppose you will get kind of idea. You can investigate it more yourself, but I personally prefer Perlin noise because it's a very soft noise. It's a very beautiful, very easy to use. And you no longer need a get list length. You can directly put this vector list into vectors and it will work. The only issue that you will realize is it outputs a value. So it's not outputting the vector as the vector wiggle or random vector. So here what you need to do is combine vector and put these vectors into the B socket. And once you evaluate that, it will just add kind of the noises, and you can evaluate that as you wish and do whatever things you want. Also, you can actually change the frequency. But the whole point is this kind of generation is very coordinated. So from point, you can see even if I increase the frequency very high, it's still a kind of visible wave. You can see the general structure of how this wave actually looks like. So what you can potentially do is to put all these seeds back to the inputs, amplitude to the input, frequency into the input, and remember with these offsets, it's possible that you put this vector as a whole offset, or I personally just put a single combined vector. So I only use a single axis to define its offset, and in this case I will choose Z, because I think making it up or down offsets is more, it feels more kind of wave nature. And it's also possible that you put the octaves back, but I don't usually use this function anyway, so I never put the octaves into the preset. And this is basically it. Just to avoid the confusion, sometimes I just you need to rename that noise amplitude, noise frequency, and so on. And I'm going to name the offset as the evolution. And it's possible that you put a time info node to the evolution to evolve itself, as it has been shown in the demonstration. One thing I have to remind you is because of time limitation, I don't want to make this tutorial too long, so that I didn't tell you another preset, but I have made a preset which is called Perlin vector noise. And this preset definitely will be included in the library once you download that. This preset is basically just to repeat these functions 3 times with different seed. So basically what you do is just duplicate 1 times and duplicate another times. The difference is one goes to Y and the other goes to Z, and so on and so forth. So it's just basically just a repetition. There's not much secret within. But you can do that by yourself, or you download this preset from the Gumroad or whatever stuff. It's just I'm just telling you the theory about how it should work. So now we have basically this node, and this is completed. So let's just call that wave generator, and you can name this as a loop or single. It does not matter. Let's just loop tutorial. Okay. So if you made that into presets, after it goes to file and startup, whatever, and you can call that wave generator loop tutorial. So now we have all this value and stuff, which is kind of very nice. The question then is, how can we actually generate multiple waves using this preset? So here's basically concept that now we're using a single controller to decide where the wave will originate. However, this socket only accepts one object, and I need to input multiple objects. And if you have watched my tutorial about loop, you probably understand in this kind of situation we need to use a loop. So now we are using a group input to make these presets. However, because this socket is not vectorized, does not receive a plural, does not receive a multiple inputs, then we need to use a loop. So let's take a loop input. And I'm going to use the iterator and take an object list. So object will be the iterator, and all the rest will be into the parameter, including the vector lists, wave frequency, wave amplitude, and many other things. So I'm not going to spend too much time to put all the stuff into the socket, but then you need to get a kind of idea about how it works. However, now the question is, if I invoke this subprogram, so select the node and hit W, goes to right, and now we have this our preset. So waves generator, the plural generator, or you can name that as list, as I did. And what you do is you put a single vector into the vector list. And let's generate an output. Let's take a vector list, because its output should be vector list, right? And we need a input a plural. So let's take a collection info node, select our controller, and put all objects into the socket. And let's take a look about what we actually see. If I duplicate this controller, and you can see we have two waves. However, one thing I have to really warn you is, if you take a look with these distributed matrices, and if you hit W and it goes down to the viewer, and let's take a look with vectors, we are outputting 1225 vectors. However, in these vector lists, if you take a look, we are actually outputting 2,450 vectors. It's double to the original amount. It's because this loop will be run 2 times. And from loop to loop, they're independent to each other. So in the first loop, I'm outputting this amount of vectors, 1,200. And in the second loop, I'm also outputting basically the same amount of vectors. That's why the double amount. So it looks like that you are actually generating 2 waves. But here's you need to be aware about 2 things. One thing is that these are 2 different waves. And that's why they are not interacting with each other. As you can see very clearly, that if you take a look with higher resolution, you can see there's actually 2 waves that has nothing to do with each other. They seem like overlapping, but they are not additive to each other, so there's no interference. And if you think about you're actually generating more waves, it actually does not help the saturation at all. So it's basically just not a function. in the way you want. So the question is, how can I actually get them to interfere with each other? So instead of outputting 9,000 vertices or vectors, I want to have the same output, same amount of output. The method is actually very simple. So if you have watched my advanced feature of loop, so you understand if I would like to connect loop or make the loop depends on each other, like the second loop is depends on the first loop, then I need to use its advanced feature. So let's hit the N and go to its advanced setting. You can see there is a reassign option. So I'm going to reassign this vector list. And I put the result back in. And here I'm going to use these reassigned vectors as an output. So here I'm doing two things. One thing is the first step I use the reassignment is because I want the second loop to be based on the first loop. So once I generate the first wave, and the second wave will be on the top of the second wave. Okay, get a kind of idea? And the second thing that I'm generating an output instead of using the, so I'm using the output from the parameter instead of using the generator, is because I want to only output a set of vectors. So instead of having 9,000 vectors, I'm having 4,000, about 5,000 vectors in this case, which is the same number as the input. If I keep the generator output, so let's still take a look with that. Using this vector list output, which is normal. And to distinguish that, you probably just name the original vector input. So you can see what we're looking right now is the vector input. But if you take a look with the vector list, it's still 9,800. So it does not help the situation at all. But in this particular case, by looking at these vectors, we have our 5,000 vectors, and we have the waves interact with each other. So you can no longer see the vertices, which is actually under the first wave, and you can duplicate, and you can see kind of interference that the slope is a little bit lower and jaggy and so on and so forth. You can test with an actual mesh to see how it actually looks, but it's basically a very interesting feature. And as I increase the waves, you can see the first two waves has been disrupted with the third wave, which is very large, very huge, and so on and so forth, because they are depending on each other, and so on and so forth. So you can play around with all this kind of setting, but this is basically all about it. So let's delete this vector list. So this wave generator list is actually, at some point, is much simpler to actually build, but its function is very powerful. And basically, it's it. I don't want to go too much detail, and I think this is really finished. The major concept has been explained, but you can definitely optimize the design as you wish, and fulfill the rest of function, like duplicating all these vector noises and so on for yourself. Again, all these subprograms will be released very likely in this week, so you can check this channel to see if there is a subprogram release on Gumroad or whatever stuff. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.